Okay, I think we're live. Uh, let's see. Yep, we are. Right. Hello, everyone. Welcome to another day where we create a game engine in Golang from scratch, mostly. Sorry about last week. There were some things and we didn't have a session, but today we'll make up for that. And I don't know if we'll demo more physics things, maybe. Let's see. So this is where we left off. This doesn't look too much different than what we had, but we actually created or started creating a lot more abstractions and some structure into the engine, including some materials, meshes, and so on. This had some work done behind the scenes, and I want to cover that before we see what to do for today. So we actually had more things here. I did push some updates, but we had some buffer things that we wanted to do, but that was low priority. So I said, you know what, before we go ahead, we should probably do that. So I want to discuss that a bit quickly before we go forward with today. So what we had is, if you remember, we had some VBOs, right? That was kind of, if we loaded the 3D model, so we needed things like, okay, we need our position, we need our normals, and things like that, right? We need our indices, vertex colors, and things like that. So any per vertex information, we were loading that into separate buffers in on the GPU, on VRAM. So our buffer class was set up to handle only that. So each buffer class was really set up to only be one buffer. So what we ended up having is per model, per mesh that we load, this might be the positions buffer where we have kind of XYZ of the different vertices. And then here we're going to have a different buffer with a different layout that had normals, and then the colors, which would be 4 components, not 3, because we have RGBA, right? So that would be RGBA, something like that. It's not really an R. Okay. Yeah, so now ideally, there's not really the best way to do it. Ideally, since we're loading all these things at the same time anyway, why don't we just make one big buffer and put them all together? And it might be as well more efficient, since the GPU has all the memory next to each other, essentially. So instead of all of this, we need to set up our buffers in such a way that we can say, hey, the first 3 components, let's say the whole thing is floats, the buffer of floats. So the first 3 components are going to denote, are going to denote a position, and then maybe we'll put the normal, doesn't matter, the order doesn't matter, but we'll put all the information of one vertex next to each other. So now again, we have X and a Y, a Z, and then we might put the colors. So this could be RGBA, and then again we start with X and a Y and Z, so on. Now all of this up to the A, that would be one vertex, right? That's the information of one vertex, and then from this vertex, pieces of it would be specific things. So this part is so we have this part, and we have this part. So this would be the position. Maybe these are the normal information for this vertex, and then colors. And you can imagine if we have more things, like if we want textures, we'd want UVs. So we plug all these together, right? Now, when the GPU loads, all the information for one vertex are contiguous. It can just take all of these and load them into the shader, and then the next one, the next one. So the calculation is a bit different. Before, all our stuff had an offset of 0, but now that's no longer the case. Because, for example, the normal, so the position, the first component of the position is directly there. It's at offset 0. But the normal, even for the very first vertex, is at an offset of, let's say, 3 floats. That might be 12 bytes. Right? We are talking about 32-bit floats. That would be 12 bytes. So that'd be some offset, and then the color some offset. So depending on how we structure it, the offsets of things would be different, and the size, like these things, we need to know the size and the layout of our elements. So we need kind of a fundamental restructure of our buffer class to not be something that holds one type of data, but rather an array of some number that is variable, right? Could be more or less some number of elements, I call them. So position is one element, then the normals are another element, so on. We can order them in any way. Then we can process essentially, okay, where do the normals start, where do the colors start, and so on. So this code is already written, but we can go through it. So we have a buffer class. Looks kind of similar to before. We have a VAO as usual, and then we have only one VBO. And like before, where we had so many. So one VBO, and per mesh, you don't have to set that, but you probably will want that. So we have a separate index buffer, right? And then how many indices, which are useful, and then the stride, which is the size of one vertex. And then, so these are just the IDs for OpenGL or something else. And then we have the actual elements that make up the buffer. So for example, the colors, positions, normals, UVs, whatever it is, the elements and their ordering. Now, if we go look at the elements, they need to give us enough information. Each element has an offset into the buffer, right? From the beginning of the vertex, and a type. Now, element type is nothing special. That's what we had before. Is it a float, int, vec2, vec3, and so on. I made some functions to convert to GL types, and each one has some size in bytes. So that's just the size of one component of the element. So even the vec2 or vec3, all of them have the same size, which is 4 bytes. And then how many components for a thing. So vec2 has 2 components, 3 is 3, and so on. And then the size is the size in bytes, right? Which we'll use to calculate the offset essentially. And then we have some more enums, just buffer usage. That's from before, nothing special here. So now the buffer is created in a slightly different way, where you say, I want a new buffer, and here are the elements that are going to make up the buffer. And if we look at the mesh class, for example, we have, where are they? Are they here or in the material? They're here. Let's see. New buffer. Where is it? There it is. Okay. So we set it later. In this case, we're setting it set layout. So that's the layout. So we're saying, this mesh has a vec3 and then another vec3. So this could be, let's say, the position, and then after it, there is another vec3 that could be the normals. And then if we have some colors, then we would add another piece, which would be a vec4. Actually, this should have this check. This check here, right? If we have colors, we add that. So if we have UVs, we can add that, and the order doesn't matter much. We just need to know what the order is. And then we set those. We set layout. Now, what set layout does is it calculates, depending on the size of each element, where in the buffer it is. So we have a vec3, and then a vec3, and then a vec4. So the first element is going to have an offset of 0, right? And then the second one, which is, sorry, this element, that's an offset of 4 plus 4 plus 4 bytes, that's 12. So 12 bytes, and then the color is at an offset of 12 again, so 24 bytes, and so on. So it just calculates those because we'll need them when interacting later on with OpenGL. And then each buffer knows the stride. So how big is one single vertex in bytes? So if that is our vertex, right? 2 vec3s and 1 vec4. So we have like 24 plus 16. That's like 40 bytes. That's our stride. So it calculates all this information. Very flexible, very nice. And then we don't need all the flattening we used to do before, but we do have an interleave function where we load all the information from the mesh that we want, and then we just say, hey, here is the order. So you can see our ordering is vertices, normals, and then colors. And if we don't have colors, then we don't do anything. And then it just puts them in one big array instead of the data structure they want. So we just put them in one big array, and then we take this float 32 and we just plug it in set data. I hope this was clear. If anyone has questions, please ask. But yeah, so that's kind of, we now have interleave data, so we only have one buffer, and then of course we have the indices which we take from the faces. Nothing special here. I think so it's simpler and a lot more powerful than what we had before. And I cleaned up the API as well to not kind of hard code OpenGL, and instead have functions to get GL types. Now drawing is very similar. So where is so we had material just like before, and then we load the mesh. It's just that the internal buffer structure is now changed. That's why it's nice to have these kind of abstractions. And then when we come to draw, let's see, we can use, okay, give me how many indices, in the buffer and so on. Oh, one thing is also the material, I think, which needed a bit of change, I believe. Let's check. Where do we load do we turn the mesh? Where do we do the GL? Set data. So the set data does this. We have just two functions, setting the entire buffer all at once and setting the index buffer. We don't have functions to change, let's say, only the normals. Maybe you don't want that, but for now, we just take this and we say, hey, this many values, they are all floats, 4 bytes each, so multiply by 4. And here are the values, and for now we are hard coding to static. I'm not sure if that's the best, but maybe we want to control these in the future. Let's see. But yeah, that's about it really. And then we have a bind and bind. I'm not sure if we did this on stream, but I did change them to bind and bind instead of activate and deactivate because that's too long, too annoying. Right. So that should be it. Yeah. So that's, now we have interleave buffers, and of course it does work. Same as before. There you go. Right. Everything's good. Okay. So now for today, let's see, what do we want to do? Yeah, so we do have the engine. We don't have a loop yet. We're kind of looping ourselves. And, rendering setup, I'm not sure what we meant by that. Material system can be improved. We don't have really an object class, and we don't load textures. Textures are, it's weird we still don't have textures. We might do that today. I was preparing for that, I'm not sure, but I also want to work on the engine stuff. So right now we kind of only have one instance of the engine possible, because we're using a package, like we have an init, and there are some global stuff. I think we should keep it this way. We can introduce like an engine struct and put everything inside, then you can have multiple engines, but I really don't see the point of that, and would overcomplicate some of our other packages. But yeah, I think it's better to just keep it this way for now. Yeah, so we have this. I guess I'll keep it. Hello. Yeah, for the actual loop, what we can do is we can have an engine interface that we call. So you kind of have, engine.run, and you just give us a struct and we run that. We run the loop on the struct, and you're required to implement some functions on it. That might be the way. Or we give you full control like this. Yeah, I'm not sure. What do you guys think? Any ideas? Because you might want to know, for example, oh, I want to put something between the input and the logic, or change the order of things, or even pause things. Like, oh, I want to pause the physics simulation for a few frames. If we handle everything, then that is not possible anymore. So we have to think about it. Yeah, it's really something. Oh, and I think what we mean by proper rendering setup is we do want our rendering on a separate thread, probably with some kind of submission process where we send things to be rendered, just like mGUI does, essentially. So mGUI prepares these things, and then we just retrieve it, loop over it, and then draw it to the screen like this. That's probably what we want. So we can do that, or we just do textures. I think let's keep this for now. Let's keep it for later. Think about it a bit more. Let's do textures. It would be really cool to have some textures on the cubes. So I have this, which is just a cube. I put a texture. It's a PNG image on it. We don't have any way to load PNGs or read the texture data, nor load UVs into the to the shader. None of that. So I think let's do that today, or try to. So I already exported that. So we have in resources, we have something called textured cube.fbx, but we're not loading it yet. So let's do that. Now let's load. So let's do a text cube mesh. Text cube, and it's just text cube, right? Text cube mesh. What's wrong with you? Why are you sad? Oh. Now, yeah, so we have the buffers and so on, some information. So the mesh on the buffers, let's just print mesh name. I just have that. So it's happy. Okay. Now, our mesh doesn't load UVs, and neither do we extract it from this thing, from Asympco, right? It does load them. At least it gives us the file names. Unless the meshes are embedded into the file, all we get is a path to the textures. Sorry, not the meshes, right? The textures. If they are not embedded in the mesh, then what Asym gives us is simply, hey, here are the textures and the different types of textures. And there is a path to them. And it's our job to actually go and load from disk and so on, whatever we want. So first we have to actually extract the textures that we care about. So maybe, we only care about the diffuse texture or something else. Because you can have a ton. Like here, Blender has, I think, physically based rendering, in this case, enabled. So you have roughness and, diffuse, alpha, whatever you have, height maps. For now, we just care about diffuse. I actually don't remember how Asymp works in this case. Let's do our scene. We get all of that. Let's do something where we say, load diffuse textures. And then how are we going to do that? So I think in the scene, from the materials, we can load textures. One mesh should support multiple materials. If you have a character, then different parts of the body might have different materials, but we don't have that yet. Not sure. But like, yeah, it has references to materials it uses. I think this is what Asim does. So if Asim gives us a mesh, and each mesh tells you what the material index is. I don't know how it handles multiple materials, but it does give you which material, and then materials are handled separately. So we have just a bunch of materials. Now, I think what we can do is if the scene mesh, let's just print for now. Let's see, scene mesh material index. So if we don't have a material set, we get that. Okay, so it's always 0. Mesh name text cube, yeah, it's always 0. And we know like texture. Okay, UVs. So we do get UVs on the mesh itself. So that's what we want to load. It's either empty or has length of. Okay, so for now we just load UV 0. We can have up to 8 on ASA, up to 8 UVs. So we'll probably want that. But first, does it make sense to load UVs if you don't have a texture? So let's do texture material, or yeah, material index. So if we always have a material index in the scene, so textures, does it actually give you the proper textures? Unless they are embedded in the thing. As they say here, normally textures are contained in external files. So yeah, compare texture stored in a file. Yeah, so we need to get it from the materials actually. So let's do mat scene.materials, and let's do scene mesh material index. Okay, then the material has a bunch of properties which we can query for. So we can loop over the material properties, and we can ask for what it is. I think get material texture counts. Ooh. And then we can get, okay, we can see if they have diffuse textures instead of doing it this way. So here's the material, and what do we have? So we want texture type diffuse. Perfect. So instead of this, we can say if we have more than 1, or if we have more than 0, let's see. So if we have more than 1, then I guess we can ask for it. Get material texture, material, and diffuse. And for now, we'll just get 0. If there are more, I guess we could load them, but for now, let's get 0. And yeah, text info and error. And if error is not null, well, for now, I guess let's panic. Logging dot if failed to get material texture. Index 0. Right. Error is, I don't know, is it E? Let's see, I guess. All right. So now texture info dot path. Yeah. So we get the path to the file. In that case, let's just print now path. Let's see. There we go, perfect. So only in one case, so the other guy, we loaded 2 or 3 meshes, two meshes, right? We're loading 2 different meshes, and we got this only one time on the second mesh. So that's the path where we can load it, and let's have just the mesh name. All right. So now that we have this, question is, where do we load the texture? Do we load it directly on the GPU and store references? Yeah. I mean, you could load, because now we are getting into the territory of materials, which are not part of the mesh. But I think some, you can have them as separate things, right? One material can be assigned to multiple meshes. Yeah. But at least for now, I think that's where the asset loader really comes in. Because this is kind of global data, meshes, materials, so on. This can be global data, and we need a system to keep track of everything. So you can say, hey, get me this mesh, or get me this material, or this texture, or whatever it is, without loading in again. And we also need something to load the actual bytes into memory. All right, let's see. Let's get to our friend. Let's see how to do textures. So yeah, at least for now, we should load the texture coordinates, which are vec2. It's just a bunch of coordinates per vertex that tell you where, where to sample the texture from. And unfortunately, the coordinate system is again something else than what we were used to. But bottom is 0, 0, top is 1, 1, and then you just say, okay, sample pixel from this position, essentially. So you have something like this. And then how to scale it, and then we just need to upload to the GPU. So I guess let's do one thing. If we have a texture, let's upload the UVs. Okay, let's keep this now. In here, we can say if the scene mesh texture coordinates. So channel count is like, is it a vec2 or vec3? And you can see it's either number of components is either empty and or has length of vertices. So for now, we'll only support UV0. So let's take so we say if we have UVs, then we want to append, so maybe after the colors, right? Actually, I want to keep the colors at the end. Let's put the UVs before. There we go. So if we have UVs, we can append a vec2 to our buffer. We have position, normal, UVs, and then the colors. Okay. And then we need a function to help us load all of this. So here, right? Yeah, raise to interleave. Oh, it only supports big 3s and big 4s. Do we use this? Get? No? Oh, we do. Well. Yeah, we need to update the interleave function to support essentially v2s. Or not. Well, okay, so let's do one thing. We're getting vec2s. Asmp is giving us a vec3, but we know the third component is useless to us. So we can, okay, let's do this thing. Let's say e2s, and then one array should be set. One array should be set, both arrays. If this thing is equal to 0, or yeah. Say otherwise, if then that's probably a very ugly way to interleave buffers, but you know. Okay, and this assert needs to be different. Assert one of them should be 0. So what we need is two of them should be 0. Say v2 or v3 should be 0, just so we don't have a big statement. And v2 or v4 should be 0, and v3 or v4, yeah, there always should be 1. Okay, so we have now this information, and in here, let's actually make this into an array. I guess we want this type, right? We have arrays to interleave. And at the very least, we do want, you know, v3s to be scene mesh vertices, and then we have v3s, which is scene mesh dot normals, and then we have conditionals. So if we have some colors, then we're going to add the color set. So this guy is going to be appending all this. There you go. Why are you not happy? Why are you? Is not a type. What? What's wrong? Ooh, is it? No, it's correct. I'm being confused. Wait, what? What is the issue? Because it's being confused about the naming. Ray 2. Let's call it that. Okay, yeah, so it's confused about the naming. So now if we have colors, then we are setting this thing, right? And so we're adding this to the arrays. I don't want this. I don't want this. Yeah, don't want this. Now we just have interleave, and we give it our arrays, and we get back our values here. Now, before this, we do want to say, so we have to match the buffer structure that we set up. So texture coordinates come first. So we want this check. Now, if we have texture coordinates, then we do want to set, in this case, the sorry, not this guy. We want to set the v2s to something. Now, what we want is for all of the texture coordinates 0, we want to drop them into a v2. So let's make a function that does that. So func v3s to v2, right? And that just takes v3s, which is an array of this guy, and returns an array of this guy. Now, so v2s is an array of vec2 with the length of v3s. This will be a bit more efficient, potentially a lot more efficient. So we set this into len of v3s. So what we'll do is we'll only take the first two components, data, this thing. So v3s I dot x and dot y. That's it. And we return this. So we keep only the first two components, and then we say, right, v3s. Wait, why are you not giving me the function? Two v2s. What's wrong with Visual Studio? All right, there we go. So we append this. So we have, so normals and vertices are always there, and then texture coordinates maybe, and the colors maybe as well. So we add them, then we interleave all of them into one big float buffer, and then eventually we set to the GPU. So now we need to fix this. So we need to check that this is bigger than 0, or now potentially the v2s are bigger than 0. And we say, hey, stuff. So yeah, okay, so else v2s, okay, it's not the same length. All right, so if this is equal to v2s, and same thing okay, so I think that's it. We have added support, hopefully, for this thing, but except that this guy is going to get 2, right? So what we're doing essentially is we want to know what's this? Else. All right, v2, v3, v4. Okay, so to interleave the buffer, we want to know how big, how many floats are making up the buffer, right? So first thing that must happen is that they all must have the same size, because this is vertex data. So if we have 24 vertices, then we must have 24 of each component, 24 position data, 24 normal data, UV data, everything. They all must match. So if there is any mismatch, we should assert somewhere here, right? This will assert, and the assertion will fail. Now, since we know how many elements we have, but we don't know how many floats. So if we might have 4 vertices, So 4 positions and let's say 4 colors. That will require per position, we need now 4 floats, and per color, we need 4 floats, right? So with that, we can calculate how big the final buffer is going to be, and this is what we do right here, right? So we are calculating for every element, okay, how big is the final float array going to be? Once we calculate that, so here we can say calculate final size of the buffer, right? Just buffer, and then all we do is we loop over all of these in order to maintain the order of the buffer, and then we set those, right? And we do this get thing, and we destructure it. So actually, yeah, v2. Hey, did I make a mistake here? I should do this. If v2s are bigger than 0, return that. Otherwise, this. Otherwise, v2, v2, v3, and v4. Yeah. So return one of them, and we get the buffer. Hopefully, nothing explodes. Hopefully. Okay, very weird, but you know, it's doing something. I actually like the color. Oh yeah, it's slightly broken. Would be the positioning. Did we break the position of things? Where's the layout wrong? So the layout has these two. Oh right. So this guy. If the 0th texture coordinate is more than 9. Okay. Yeah, because one vertex can have up to 8 UVs in this case, right? Loaded by ASM. So what we care about is the first set of UVs. You might, usually you'd at least support 2, which we can do, but for now, we can just support the first one. So if we have the first one, then we're going to load it, and we're using it. This is correct here. I don't know if this will change things, but I don't think so. Nope, it's not. Yeah, it's doing something. And what we want is it should just load and not affect anything, really. So we go through the v3s and we just set everything, taking x and y and those. v2, v2, v3, v3. Yeah. Total size is into 2. Here 3 floats, and then here 4 floats. Yeah. This looks okay. Anyone notice where the issue is? So this doesn't matter. This is not doing anything. We're just checking. And let's say vec3. And then the color sets, and then we have again vertices, normals. And then these v4s with the color data. We interleave everything. Okay, so let's see. First of all, I think we need a format print line. Values, size, or length. Line values. Okay. Are we loading the second one first? What? No. So this doesn't make any sense. Why is the original cube having more values? Have less. Maybe I didn't export something. Post process, triangulate. Do we have normals? Let's check that. Did we forget to export normals? normals, scene mesh, maybe 24. No, this looks fine. 24, 24. This looks okay. So it's not that. Any ideas? Let's put that there, there. So when we export, what data do we have? Okay, forwards minus z, y is up, geometry, normals. I don't think any of this matters. So the original cube, because we're not displaying the new cube, just the original cube is being screwed up. Even though it should not load the textures. Is this list have texture coordinates? What? Okay, so let's say text coords. It does. Well, even that should be fine, sure. We're not using it for any. I don't remember the first one being textured, but even if these look like broken normals. Yeah, it seems the layout is probably wrong. Vec2, Vec3, and potentially here a Vec2 again, and a Vec4. Okay, let's do a check on Vec2. It's a float, yes. It's 4. Number of components 2. Size for Vec2 is 24. Oh, these are fine. So they all have the same thing. So okay, let's print the layouts. Let's see. Layouts. And we can do what do you call it? Is it on the material? No. Where did you put it? On the mesh? Get layout. Let's see. Okay, so the first one has colors, I think. Yeah. So 0, 5. I assume these are the positions. And then this. Here it's 4. And these are colors, right? Okay, let's just check what the layout means. To get layout. So an element has an offset and an element type, which is this. So we have offset 0, then offset 12, yes, then offset 24, then offset 32. So 12 is three floats, which is correct. And then this guy is at 24, which is again correct. And one of them is type 5. So this is a vec3, a vec3, and this is a vec2, type 4. Yes, correct. So these are correct. And this guy just has colors, the other one doesn't. And then 32 because, wait, this looks wrong. 2 floats. That should be 30, right? This guy is a vec2. So here it's a vec3. 4 plus 4 plus 4, that's 12. That's the offset. And then this is also vec3, so that's again a 12. That becomes 24. This guy is a vec2, so 2 floats. 4 plus 4, 8. Sorry, I cannot count. Yes, it is 32. That's correct. So then, are the offsets wrong? Or the offsets? No, I mean, loading it might be problematic. So set data. Is set data exploding? 4 bytes into this, into this. That's fine. This is very weird. Then in this case, why is this guy having less? Okay, that's why it has less values. That makes sense. So the layout does look correct. Is the interleaving wrong? Would be, actually. This is very finicky code. Okay, V2s. Just look at the arrays. Vertices, and then the normals, and then the texture coordinates, and then these guys. And let's make sure this function is also correct. Is I yeah, I mean, this should be okay. And then we set it on the V2s as V4s. Okay. And then we interleave. This guy, and then so how many vertices do we have? Let's see. So scene mesh. Okay, 24 for both, makes sense, both cubes. So we get a calculator out. So 24 vertices were multiplied by, so one position, that's 12 bytes. Wait, let's do this. So 12 bytes for position plus 12 bytes for the normals plus what do we have? 12 bytes, no, 8 bytes for the UVs. Right, that's 32. That's the correct offset. And then the colors add how many? They add 16 bytes. Right, and that gives us 50, I think. Right, just add 16, 48, right? And that's one vertex multiplied by 24, unless I made a mistake. Okay. So let's then print this. Values. We did actually get the values. 288. 288 into 4. Yeah. So we actually do have the correct things. And if you don't have these ones, so you get only 12 plus 12 plus 8, 32 into 24. That's 768. So let's do 192 into 4, 768. Yes. So these things are actually correct. Maybe we do need to update the shaders to match. Either that, or because I assume it just ignores the rest, since there is, nowhere to put them. So fragment vertex shader. So we have, oh right, colors are in the second position. Right. Vert UV0, because we might have multiple UVs, and that's vector. right? And then yeah, we output whatever we want. Yes, that is correct. Like completely. I think we need to edit somewhere else as well to change the positions. Oh, that's already fixed. Cool. Very cool. Now, set data. Is it in the material that we set these? Or is it here? I completely forgot. Okay, attributes. Where do we set the attributes for the thing? Okay, attributes. I'm GUI. Set attributes. Okay, right here. Set attributes, right? So in this case, we're relying on the ordering actually. We are relying on the ordering. It might be dangerous. If like we have colors, we don't have UVs. So maybe we say you always have UVs, which might make sense. Let's do that. Let's not suppose that we cannot have UVs. So you always need some UVs. So let's say then this is just a permanent part of this guy, right? And we can actually assert, probably we don't need that, but let's do that. So the length of, what do you call it? Scene mesh dot texture coordinates zero is bigger than 0, right? There must be a UV 0, or mesh has no UV 0. Okay, so that's that, and then I can just get rid of this as well. Get rid of this and plug it in here. That's one piece of the puzzle. Is we have support for loading UV, which is nice. Now, as we load UVs, let's load textures. Let's just do something with textures, and then we can have a whole system to do it nicely. So you get the textures. So first, we do need. Let's probably just make textures. Textures dot go. Func load .png. File string texture, right? And it returns a texture. So all of these things would probably all be moved into the asset loading system later on. Materials, meshes, textures. For now, we can keep it separate. And so here we can call, textures dot .png. We'll assume it's a PNG for now. So let's do that. Oh yeah, just about. Cool. So I think Go does have, yes, it does. It does have PNG loading. Then we can do, what do we have? Oh, it's a decode from an IO reader. All right. So let's do os.read file Okay, perfect. So let's read the file, get the bytes, get the error, and if error not null, should we panic for now? We don't. I don't think a game expects fast to not be there. Well, that's an error for now. So we say, oh, it is something bad. Texture error. And that's that. Oh man, VS Code struggling again. Okay, we need. Okay, what's wrong? Texture. Okay, now we can do png dot decode. Come on, VS Code. So maybe bytes dot new reader, and we give it this. There we go. Close. So we get an image.image and an error potentially. Okay. So image error again, and we can say the same thing. So what does an image? Wait, what? Point. Oh come on! Just give me the pure pixel values. This is really annoying. So we want the bytes because we're going to load into VRAM, and we just want the pure bytes. Like here's the RGB values. Take it and go. Huh. That is crazy because I think at is really slow. At is really slow. Oh man. Can we get an RGB? Can we? Yeah, so this is essentially what we want. We just want a bunch of pixels, something like that. You can see these add things can be a bit slow. Well, oh man. And we do get a format, which is nice. Color model. Convert. Wow, you have to convert one by one. Well, let's print color model and image dot color model, right? And let's do format and okay, so that's just temporary. And then what we want is a bunch of bytes. Do we want a bunch of bytes? I mean, yeah, let's do it for now. Not bytes. So pixels is just a bunch of bytes. So if you want to do HDR, or like, yeah, you want to load images that have things beyond 32 bits. I think that's for later. Text, it's texture, and then let's say V, you can just override it. Bunch of bytes, and the size is the image dot bounds, I think. But bounds dot, so we'll flatten it. We'll essentially flatten it. Size. Point, no, thank you. Overlaps, intersect. Hey, they have a bunch of nice things. Min max. What's a max? dx width. All right, width into height, and it's sad for some reason. Int. Oh, okay, sure. Now, let's go over and say x, so image dot this, then y. So we loop over the entire image, width and height, and we just say, you know, bi equals image dot at. We say c is image dot at xy, and then bi equals okay, RGBA. So we get those. Let's do that. RGBA. Thank you so much. So this guy is R. Oh, come on. And then what we want is +1, +2, +3. So we'll always have the same format, RGBA. We don't care what we are loading at. We'll always store it in one format. That makes it a lot easier. So RGBA. Now, thing is, these guys are what? Int 32. But we say, hey, you know, we don't support more than 255, so does this work? Let's see, open Google. So uint byte go. So you just want the first piece out of it. Because we kind of know that this guy is, at least for our usage, we'll assume that it's a 32-bit pixel. So each one is 1 byte, 8 bits, totaling 32 bits, right? 824 with an A is that. Now, do we take the lower parts? So we want only the lower 8 bits. Take these bytes. Come on. Not index. What index? B. Ooh, it's being reused. That's why. Oh, wow. You know, I say out. So out. Okay, finally. Now, I is obviously not going to work. So, how are we going to index? Well, let's just do an I here. It's the easiest way. Let me say I plus equals 4. Okay, perfect. Now it allows us to actually convert. And just to make sure we don't actually use this one, let's call it file bytes. Okay. So we're essentially flattening the image from 2D into one big array, and we'll put this guy into the pixels. So we can return now a texture pixels out, right? And no error. Any questions? Any questions? Right. That's loading a PNG, putting it in a proper format. So it's nice. Now we can have a format in case we want in the future. So we might as well do that. So we can say color format, right? Just an int. Let me say, for example, color format RGBA. Do we need to put there too? RGBA 8. So you say each component is 8 bits, making up a total of 32, and that's color format equals iota. And for now, that's all we'll support. So yeah, I think that's good. Hope it's clear for everyone. So we load code, and yeah, we don't care about the color model anymore. Hopefully, 5 plus 1, 2, 3, 4. Okay. Let's see. One way to know. So how do we know we're loading it correctly? Maybe we read it and rewrite it out again. Should be funny. Or we just do it on the texture one go. Let's see. For now, let's see if we get any errors. So text and error, and you know, for now, let's do red line. Let's just see if we can load it. Can we? Nope, we cannot. Okay. Sure. So we are off by 1. Why are we off by 1? X and Y. And 0, 1, 2, 3. Oh, right. This is how many pixels. This many pixels, and each pixel we're assuming is 4 bytes. Yes. It's out of pixels, out of bytes. There we go. Nice. So no error, 0, 0. It's all null. Perfect. So we're loading, we're not crashing. We have our nice little cubes. Hopefully by the end of today we can texture them. Maybe, just maybe. Let's see. So this guy is good. No errors. Now what do we want? So we can load textures. Let's see Mr. Tutorial. So we have our UVs loaded very nicely into memory. We have this guy. Texture wrapping. Okay, so now we need to do this kind of magic to load. Okay, so these are just settings for how you want the texture to appear. Sure. Bunch of base colors, texture filtering. Yes. Can you show me the entire thing, please? Okay, so they load the image. We need to generate some textures, bind them. Yeah, so it's the same kind of general process as we did before for the buffer. So we generate something, we bind it, and then okay, we specify some options, width and height. Oh yeah, let's take that. Let's include this into our texture information. So let's say width, int, height, and textures. So width is, we assume. Oh, what the hell was that? VS Code, what are you doing? Height, perfect. So now we have this information as well. And width and height, RGB, you know, for us will be RGBA, but sure. Free that. All right, so that's the whole thing. That's the whole thing. Applying textures, then, you know, H coordinates, interleave buffers. We have this. No, it's really cool. It's two components. Yeah, so it's sometimes called S and T, U and V. All of these are really the same. So you have this. Okay. Okay, so we need this sampler thing. All right, let's start here. Let's copy this guy and go, and hopefully it's not that hard to integrate into the material. I don't know. So this is what we need to do. Okay, get rid of SDFI, load texture, simplify, assuming we have a texture. And so we have this, okay. So that's the process. Now, do we hard code in the material? Because we don't have material generation yet, so yeah, I'm not sure. What do we have? So set attributes and then enable specific attributes. So here we're just setting all the attributes in the buffer where we enable them, and we set an attribute pointer. Are we doing that here? Is there an attribute pointer in all of this? Attribute pointer? Yes, there is. Yes, there is. Okay, so this doesn't change. It's still a float. Okay. So it kind of takes the okay. Should we load it as floats or keep it as bytes? It seems we should yeah, this should be a float. So that's another thing. Good to know. So we can either represent the pixels as values from 0 to 255 or as values from 0 to 1, floats from 0 to 1, right? Either integers 0 to 55 or floats 0 to 1 to denote how strong the color is. In this case, we are doing these guys, but doesn't seem that's how Mr. OpenGL wants it. Yeah, I think that's what we did in the shader as well. So if we look at the fragment shader, yeah, it's floats with 0 to 1. Okay, so let's do that. So floats, so we have a byte. It's going to be 0 to 255, and we can just divide by that. And this would be float 32 as well. Well, now I guess we can just convert to float 32. If we won't do anything, but then we divide by 255 to make it between 0 and 1, because we assume, that this is actually between. Okay. So we hopefully have values that make sense. We'll know soon. Okay. So you have this guy should work as is. Hopefully, we have all of this more or less automated in this component count. This would be correct. Stride, so on and so on. Okay, perfect. So we have this guy. We have our UVs. We don't have all of this to generate the texture. So is that just loaded somewhere? Should we do that as part of making the texture? Yeah, I think. Yeah. So not the material, I believe. Let's do it here. So we load the PNG and part of the texture info width, height, pixels. We can just have the text ID, and that's what are we doing with that in the buffers. U32. All right, let's do U32. So now, once we have that, load from disk, repair OpenGL stuff. I don't like that we're coupled to OpenGL, but you know, for a long while that's probably fine. So let's copy all of these and do them one by one. Let's go. So texture, we do have GL gen texture. So let's do this. Gen textures, right? We want one texture, and well, here's the ID. Okay, so let's take this guy out. Text and text and then out. So all of these essentially become text.pixels. Okay, perfect. Now, gen texture, please put it into this. That's done. Bind it, sure thing. We'll do that. GL dot. What do you have? Texture 2D, is this correct? Yes, it is. And yeah, that's just the texture ID. There we go, and we do GL. Perfect. Nice. Next, we set wrapping filtering. So here we just set options. So this should be ideally configurable at some point. That's what UIs are useful for, honestly. Right. So we'll do all of those. It would be really cool if it works this easily. Okay. GL dot GL dot. Okay. So on the X and Y, we have repeat the texture, and then you know mip maps, linear, and then filtering. Okay, minimum, maximum, minimize, maximize. Okay, as it's stretched up and down. So now, what do we have? Load and generate. Okay, so we did load already, and now put it, upload it to the GPU, I assume. What's this level? Ah, that's the map level. I don't think we do that. gl.rgba. For now, that's what we'll do. We'll always assume it's RGBA. And then text.width and n32. Well, let's do that. Do that. Text.heights. Borders, we don't want that. Format, that would be the same, RGBA, and then gl.inside bytes and the data, which is text.pixels. There we go. Ooh, I did that. It actually knew how to do it. And save pointer. So I think it's not necessary to do mip maps. I'm not sure we really want that, but you know, yeah, this is another thing that would be configurable, right? There's a lot, really, a lot of things that you would probably want to do, but you know, this is that. Now, unsigned bytes, so that would give us 0 to 255, but it seems that it does the conversion automatically. It does seem like that is the case. So yeah, width and height format. Wait, is that they loaded as bytes? Oh, then where did we see the float thing? Oh, right. So it does that automatically, it does the conversion automatically. Okay, okay. That's even better for us, honestly. So OpenGL seems understands all of this, GL float. So it does GL float anyway. Okay, okay. I think no, sorry. Yeah, the texture is separate from the UVs. I confused the two. Very sorry. Disregard that. Yeah. This guy wants to be interactive. I confused the UVs with the texture data. The texture data is bytes. What we did was correct, actually. So this guy is just a bunch of bytes. No need to divide, no need to do anything fancy. You know, okay, let's take those guys, convert the bytes. There we go. Cool. So that's that. We have all of this, and it's on the texture. Pretty cool. Self-contained, I like it. Now, if we did everything right, we should just run and do nothing. Hopefully it doesn't crash. It did. Okay, go pointer to go pointer. I think that's here. Yeah, text image 2D. There we go. Why are you sad? Oh, right. So I think we give a pointer to the first guy. I believe so. There we go. Perfect. Cool. That's actually going smooth. So with that, and we have our UVs, we need to set up the sampler, right? So they say, you know, there is div type for textures called the sampler. Sampler 2D, yeah, we have sampler 2D. Uniform sampler 2D. All right, so that's a uniform. Makes sense. So let's add that to the fragment shader, right? Wait, what's this? Okay, yeah, to the fragment shader. So in here, let's do a uniform. That's the texture. Let's call text1. Or diffuse texture, let's say. So this is our diffuse texture, all right. And then this is how we sample, right? So we use the texture coordinates that are coming from the vertex buffer. Vertex shader, right? We use those to sample the texture that's loaded here. So we can use this function instead of doing all of. Now, obviously, we can load, but for now, let's just see a pure. Just the texture alone, and then we can add, you know, probably you can just multiply it and to affect it with lighting and so on. But for now, let's just do a texture. Why is this guy complaining? So that's diffuse texture, and then that's the sampler, and then the texture coordinates, which should come from here. So normals and out vec2 is what do you call it? It's uv0, right? And then in here we'll have just same thing in vert uv0. This guy, there we go. That's about it. Now we do need to set it, yeah, exactly, to bind before, to bind the texture. So yeah, textures, it seems we bind it separately from the VAO. So we bind the texture, the VAO, and then we can draw. Perfect. This sounds good. I do want to connect it to the thing. Oh, what's wrong? Why are you very sad? Oh, right, it's not sad. Bird color. Actually, I want to order. So normal, and then color. Is let's just birds. Normal. Okay, bird UV in. Bird UV 0 in. There we go. Cool. Now, so we have this. It's being enabled. So set uniform will probably have one for textures. That only makes sense. So we can do it material, you know, dot, blah, blah, blah. Okay, let's do that. Let's do and bind, yeah. So here we're just binding the shader. That's enough. Anyway, so let's say, okay, what we want is on the material is to set a uniform sampler 2D uniform name, and we'll just take, should we take a bunch of bytes? That's it. I think so. You know, so data. Oh, that's done in the. We already set it up here. So when we bind, so maybe, I'm not sure if this is the best way. That's not actually how we do it, because we're setting the data there, right? So potentially we'll have a bunch of, really a bunch of textures, text IDs. For now, I'm going to just not make an array. Have this. So diffuse texture ID is a UN32. And let's see. But I think zero is still valid. So, well, let's say it's an int32. I think let's make it an array. So text IDs. There's two. And then let's just add something like add texture or something. Add texture. Text ID. And all we do is m dot text IDs equals event text ID. We should probably search as well. That might be slow. Well, keep it at that. So you add the texture, probably need the remove, we can do it later. And then on bind, we use the shader obviously. And then for each of the text IDs, we bind the texture, right? So this, and that's a V. Perfect. And then in here, we use zero program, and this is not completely necessary, I guess, but I think we can only have one texture 2D at a time, right? So it doesn't make sense to have an array, right? Let's see. Texture object has a texture image. Let's see. XY, okay. Texture 2D parameters. Okay. So for this ID, we do this. Yeah, so we upload the data. So we bind, set parameters, upload the data, and then we can unbind. Then applying textures is right. So that changes by the sampler. I believe so. Where is the sampler thingy? Texture units. There. Allocation to the texture sampler. Yeah. Texture unit is 0. Not all graphic drivers assign default value. Okay, interesting. So we have to activate and then bind. Cool. Texture 1, texture 2. Yeah. Okay. So gl.bind texture units. Or do we? Is there like active? All right, there it is. Active texture. And then we can select the texture unit. And honestly, why don't we do I? So we do gl.texture 0 plus I. That should. What's that? What are you? Int. So I gave you an int. Okay. So uint32. Since they are sequential, 0. Wait, that's not sequential. Oh, okay, that's 10. All right. Yeah. 0, 1, and then 2, and then 3 somewhere, and so on. So we can have so many textures. So we can do them in order. Bind and activate, in the order they were put. Maybe not the best way, but it's okay for now. Bind texture 0. So to this guy, we're removing. Or just okay. This looks good. We bind each texture to this. Units. Great. Before we display it. And then the VAO, and then we draw. Cool. So we can change that as we want. And this guy, this is just an integer of specifying the texture unit. So that can actually be done with, we have an int, no, so let's do set uniform int 32, and then just the value and 32. Uniform 1i, right? 1, there we go. Cool. Very cool. So we can have that. Someone can change it. All right, I think that's it. We bind the shader and we bind all the textures and we unbind everything when we're done. Why? Okay. Okay. So now, I think that's it. I think this won't do anything. At least shouldn't crash. Oof. Okay, because we're sampling something that doesn't exist. Are these words? Is this like a warning? Yeah, or some memory. Yeah, maybe some default stuff. I've never seen this before. Okay, so because we're doing a cube with no texture applied essentially, so that's fine. Let's load the texture cube in both cases. Let's see if this does anything. No, it does not. Not yet. Okay. Okay, we do need to add the thing. So simple material. Let's say simple material dot add texture ID, and we do need from the mesh. So the mesh is now loading the texture. We're not doing anything with it. That's where it would be useful to have a system that caches all of these textures. Right. All of this info. So we can get the texture IDs. Let's print it for now. Let's do a hack. Print redline text ID. But I assume it's 0. We can change it. That's it. It's 1, it's not 0. 1 and then 2. Oh, what? We're loading 2 textures? That doesn't make sense. That does not make sense. Are we? All right, we are loading the same thing twice. Yeah, sure. So 1 and 2. So it seems starting at 1, not 2, 0. Oh, there we go. Super cool. It's all broken, but we have a texture. We actually do. That's so super cool. nMage has really come a long way. Has a lot left, but it's something. What is all this banding though? That's weird. Maybe the way we loaded the buffer or we like decoded the data, RGBA is not kind of correct. But yeah, it's something. Very interesting. So this worked. This is very cool. Let's see. Should the mesh include? So normally the mesh shouldn't, just like ASM does, because the texture data can be shared, it shouldn't have its own copies of the textures. It should instead go through the texture system. Now, I'm really inclined doing that here, where it does just has a bunch of indices of the textures. Or like, oh, here's the texture ID that I belong to, and so on. What do you guys think? Looks very cool. We are actually loading PNG from disk through reading the mesh, and we're displaying it. It's really nice. Okay. You know what? Let's do something. It's the start of an asset loading system. It is not yet an asset loading system, but why don't we start that? How long have we been? Oh, it's less than 2 hours. Okay. So assets. Let's do assets.go. So func set texture. For now, we'll just do something very simple. We have a bunch of hash maps. So, like textures, and it's just a map of. Oh, we don't want to create circular dependencies in this case. Okay, we let the person. All of these would integrate into the asset loading system now. Okay, we'll do that. So all these textures, we'll move all of this, I think. We will put it in assets, and then we do textures.go. And we just paste all of this. We no longer have textures package has gone. This guy is that's a string, or actually a uint32. So you give us texture ID, and we give you back a texture. So set texture t. So you give us texture, and that's it. All we do is we say, let's initialize this, by the way. Say textures. Yes, textures. T.textID equals t. And then how do we? So when we load a texture, we need to know if the texture already exists, but the ID is not enough, because OpenGL didn't care. So maybe through actually the name, the path, but the path is too long. Well, ideas. We can keep track of textures and where they came from. And that's actually probably a good idea. Maybe the path is too much data. Oh yeah, you know what? Path string. And where's the texture? There you go. So path is just a file. Now you load it. This will be implicit now. So at the end, before we return, we just say, textures dot. Actually, we just say, set texture t of text. That's it. So for efficiency, we should load by the texture ID. We don't want huge strings being thrown around to look up. But to check if the thing exists, we can check by the path. So, we can have like texture paths. And that's just a hash set, essentially. It won't contain any data. We just say, hey, does this exist or not? Right? And so when we set a texture, we can look up. So we say if if the texture paths don't contain this path, if it's already there, then we return. There's nothing to do. Otherwise, we can set it here, and we can say texture paths t.path equals nothing. Okay, so now we can do that, and then we can have a func get texture with the texture ID, and we return texture. So the ID might be there. I was thinking about the lifetime of objects, because if we want to unload a texture or unload a mesh, I don't want to do that, but I guess, asset loading system for another day, we just want to do something. So, and we want to say if the texture exists. How do we denote that? So I guess if the path is empty, well, that's kind of we can say, exists kind of texture, and so we can return textures text ID, text and okay, right? And we're going to return text and okay. So if you want to check whether it exists, it's up to you. You can do that. So now we have this, and we load, we automatically set to that. The mesh doesn't need to do anything with the PNGs. Oh, so it's here now, it's assets. That's that. .png, we throw it out. We do want to say, if there's an error. Oh, and to make it shorter, we actually can say if if texture paths, same thing, okay, if we do have the file, and hey, we can just do get texture, and we don't have the ID, we can make it a mapping between file path and ID, I guess. That's fine. So let's do that then. UN32 and t.texture ID, right? Yeah. So now we can say, hey, get the texture. Get texture by path, and then that's just like the path, and this guy does texture paths. That should do it. There's no path, we get an empty, we get a 0, and it seems texture starts at 1, so we get a 0, and then 0 will return no texture. Okay, will be false, and that's that. I should do it. Now we can get texture by path, and we just give the file, and we return we return no. Why are you sad? Hey, we can do that. Text. If it's there, then we can say, here's a texture. Don't worry about it. So then the mesh can simply say, well, load it, please. And we can say if errors not equal to null. And you can say loading PNG failed. PNG with path this failed. right? All right. So now we have a loading mesh loading system now outside, or actually in here. So mesh can keep track of textures. Texture IDs again. You know, probably this will probably all be changed later on, but for now, probably fine. It's okay. So every time we find a texture, we're just going to say, well, on the mesh dot texture IDs, please append this texture dot what? Okay. Texture dot ID, no. Oh, that's right. And then what we can add is once we load the mesh, we don't need this guy anymore. So set mesh textures on material. We can just say, you know, for each of these IDs, simple material is going to get a texture ID. This should give us some texture cubes to look at. There we go. Nice. I still am confused with this nice look. Are we loading incorrectly, or is it just the colors and banding? Interesting. Okay, so some progress, but still have something to do. Okay, so we did this. We have some simple asset loading, which is cool. So we shouldn't now load the texture twice. So let's say this, adding a texture. We should only see this once. Actually, we need to load it twice. Right. So let's get this guy twice. We should see only one adding a texture, and we do. So that's good. The same should be done for meshes, really, because you just have one copy of the mesh VBOs, unless you explicitly want to be a copy, but that's later. Once we properly think about how we want to do an asset loading system. Okay. Now, so simple material, we bind that, we bind this guy. This guy is going to do all of this. You know, texture 0, bind texture. GL texture 2D. We might want to do, you know, texture type, but I guess that's for later. Oh, so you can mix textures, nice. Assign byte. Let's make sure we are actually loading as an assign byte. So textures, assign byte. Yes, we are. RGBA. Now it could be that we are loading the buffers could be wrong. The texture, like the PNG image, the way we load it can be broken. So all of this. Let's print these. Let's do. We'll have a ton of them. You know. Let's do. We will have a ton, but you know. Okay. And let's do RGBA. Okay, these numbers are wrong, so I guess we know. These numbers don't make sense. They're all full. What? That is very odd. Let's do byte. Why are we getting 65,000? Oh, is this beyond like? Is this more than 32-bit per color? So many. So this guy is at the maximum. 65. 16-bit. 16-bit per color. That's the alpha. That's the transparency. The transparency here is 16-bit. Exactly. That's a full. So our PNG is 16-bit, not 8-bit. That's the one thing we said, hey, you know, we don't want to support that yet. And, okay, so how do we convert that? Dot convert, image dot convert. This is really ugly code, but and very slow. But for now. Convert to what? Oh, right. So we get a model. Nah, that's not what we want. So what we want to say is load PNG as or with 8-bit colors go. Okay. Bit depth. All right, that's interesting. So, ideally we want to, since we don't care, like we're just saying, hey, here are some bytes. And so if an RGB is just more than 1 byte, then hey, we expand the buffer more. That's all we do. That's really it. We need to find out first. So let's do a print line. That's probably why we get the banding because we're not loading it correctly. Yeah. So let's print. Let's just see the color model. What does that give us an info? Hopefully. Oof. We're still printing all of this. That's not helpful. Okay, let's do a test. So we'll do divide by. What do we divide by? 255? No. Divide by this. We get a number between 0 and 1. Multiplied by 255. Okay. So this is a dirty hack, but this thing will convert them to a number between 0 and 1, and then we make it between 0 and 255, and then we make it a byte. That should hopefully, at the very least, give us correct looking images, maybe, or not. That is not correct. I mean, potentially we're still, is it still too much? Is there a better function than this? Decode config. Dimensions without decoding. The speed, no compression, encode. I mean, this thing is not giving us a lot of information, honestly. And this color model thing, all it has is a convert. Like, okay. Okay, let's do, image dot decode string. Okay, so what's this? Point register format. Okay. Anything useful? These are all new. Really. Nope, not a very good library. We need more. Gray color model. Yeah. Image color model. Black, opaque. What? Gray. Hmm. Okay, so it seems there's something called color. Really fragmented library. Let's see. RGB. 8 bits. Yep. What's an RGBA? Ooh, interleaved. What? I would like to know what an RGBA non-alpha pre-multiplied 32-bit color. Alpha pre-multiplied. Okay. Has been scaled by alpha. Oh. Ooh, okay. Dang. We don't want that. We really don't. Alpha pre-multiplied. Oh man, that's why. That's annoying. Oh god. Okay, so they just we could have multiplied easily. They want to pre-multiply. So we need to essentially unmultiply this thing. So they pre-multiplied with alpha. So except for the alpha components, what we can do is, you know, R divide equals A, right? We just divide everything. R GB. Since they pre-multiplied, so we divide to get rid of that. And hopefully, well, that got us complete black. So let's see that this guy, let's see the values. I'd like to know. Oof, they all went to 0. That's crazy. So alpha might be higher. Wait, I am a bit confused. But is represented so that multiplying by a blend factor will not overflow. 0 till A. Interesting. Want to extract the original. Okay, so let's do what's this color model. All right, any color to one form. Okay, so we want the NRGBA, non-alpha pre-multiplied. Yes, please. Dot convert. Okay, so hopefully this gives us something that makes sense. Yeah, looks normal. Now let's do this and see. Oh man, that's the same. I don't know. The colors look actually a bit better. The shapes, maybe not. I don't know. It should look like this. Yeah, there's a bit of red and glow. Banding. So that's one thing. The other thing is still 16-bit. So let's try just do the masses. This. Let's get rid of those boys. There we go. do anything unexpected to it. What? Can we get the color depth? Depth. No. Let's ask Google. Golang PNG. Any ideas? Might use some library. That's better. That's better than all of this. Okay, decode. Docker. What do we do with Docker? PNG1. All you want really is pure pixel values. It's very simple. I don't know why it has to be really hard. Ximage. Yeah. Decode, compression, encoder. Get this, divide by this guy, multiply by 55. That's that. Let's debug these values. Make sure they look normal, at least for R. Yeah, I guess. Okay, fine. R GBA. I guess so. And A, we are also doing that, which would be 1 all the time. 255. Yep, correct. Okay. So that's not helping. What should we do? What should we get? What should we try? So let's say we just want to drop 16-bit to 8-bit PNG. Gray sets. (24 bits). 8, 8, 8. We want RGBA, not RGB. These are the bytes. 1, 2, 3. Let's see. Yeah, so they're dividing and then repacking the color essentially. And RGBA, non-alpha pre-multiplied, RGBA. uint8. That is uint16. What does just RGBA give? I think oh, right. Okay, so we have these. I don't know if we should be looking at something else instead of just playing with these bytes. But really, what we have is, where is it? So image.at gives us color, which is pre-multiplied. And then to essentially unmultiply, we need to do this from the model. This is just unpacking. RGBA model. Right, that's because this so we give them this essentially, then they multiply by this guy and they divide. That's what we want, I believe. Yeah, so these are guaranteed to be, but I'm confused. Wait a second. Even without dividing, this should now be correct, because they guarantee that nRGBA is just uint of 8. So why are we getting that? You know, I expected this image loading to be the simplest part. Turns out not. It's because the API is annoying. Yeah, so we have these values, but I think let's cast it like they do here, since we know it's an RGBA. So we can do converts, you know, an RGBA dot, yeah, uint8. That's what we should get, not all of this. Okay, let's get that. C dot, sorry, not A, C dot R, G, B, and A. Great. Now what do we get? Now these look correct. This is without us doing anything, dividing or anything else. We just say bytes. Okay, let's hope for the best. At the very least, we know this is now correct. Okay, so now we are loading bytes correctly. We are sure of that. Let someone else handle it. Okay, not the fastest way, unfortunately, but it's something. This RGB. Hey. Right. So now I have this. Let's get render doc, which lets us essentially look at our buffers and the GPU memory and see what's happening exactly. So we can maybe see the layout of this guy. So launch application, executable path. No, give me image, image exe. Stop. Okay, so I think Q capture maybe frames. Get like 10 frames. Launch. Sure. Yes. Wait, what? Why are we getting a black screen? Does this make sense? Working directory, yeah. Oh, it's an old bit. So we need to, oh god, why did I run Steam? Cancel. Oh, Steam, come on, go away. Okay, let's go to builds, Steam. Launch again. Okay, so we have these. Got the frames. Now, let's investigate. So we have bind sampler, right? It says no resource. This here we are unbinding, and let's look at color paths. Okay. Frame 0. Wait, where did it go? Texture, repeat, linear. Sure. Okay. Show me the texture. So we only have one texture. Gen texture, and then 800 by 600 RGBA. Okay. 1,922,000. Just right. Now, where do we see the texture? I think there is in the view. Texture viewer. There we go. Okay. Yes, but can we see the actual? Can we see the buffers, please? Okay, so Fragment Shader gets this texture. Cool, which for some reason it displays briefly. Texture, two textures, 99.95. This one could be for I'm GUI. And this guy is actually ours. That doesn't seem helpful. We can't see the actual memory. All we know is the size. Any ideas, people? Okay, now it could be the mesh. We could be interleaving incorrectly, for example. Well, let's actually debug this just to make sure. Although we did debug it last time. Not debug it, but we saw with the non-texture cube that was actually correct. Let's see. When VS Code decides to actually run. Come on, VS Code. Come on. Debug would be better. nMage output. Okay. I have no idea what it does. Go run, runs immediately, and this guy is just waiting. Thank you so much. While it's loading, let's say, OpenGL texture banding. So what's the issue with banding? You only have 3 textures. Finally, wow. Before we do that, now it should load quickly. I think we forgot something. Our no, not here actually. Our UVs are 2D. The colors are 4-dimensional though. So in here, texture, diffuse texture, that should be 0. And this guy is, actually 1. That's the UV. Yeah. So we do all of this. We set the data. We might not want map maps, honestly. GL float. Okay, so here we just output it, and then in the sampler we do this, which is okay. Mix. Oh wow, what's all of this? Should we draw as RGB? Where is this? So we have an internal and external. So the format of the data, but then here is the internal formats. Does this matter? That's a question. Let's see, internal. Where is this? I like how it says, okay, there's one of it, but I don't know where it is. Oh, it's here. RGBA, okay. Okay, it's the so our fragment before had this. I don't know because we don't have alpha issues, but what if we for now just get RGB and then have a full alpha and see where this goes. Oh, not this. Let's go on. Yeah, still loading fine, except the banding. Okay. Actually, I think we'll do this and let's move uniforms here. Okay, okay. So let's go back into our interleave. Not sure, that's confusing actually. Okay, so we have filtering that shouldn't really affect things much. Map maps. Let's not generate map maps. Let's see if this does this actually break things this bad. Let's see. Best thing we did is we moved everything to dynamic linking. Okay, it's going to be working. So now we can just go on within a second. All right. We shouldn't need map maps. Why? Okay, so linear. Oof. So it's a filtering thing, is it? That's even worse. Okay, so that's linear filtering. At least at the distance. Yeah, the map maps were helping with that. Okay. Repeat. What do we have? Linear lines. Okay, so we need those. What do we have? Like sharp edges, two map maps, nearest and linear. Let's do maybe nearest. Wind filter and okay, I see. Oof, that's horrible, but yeah. Are these black lines all the time? Yeah, some really bad expanding. Linear map. Nearest map nearest. Right, and we need in this case to generate map maps. Yeah, it's not. Ooh, we can see it go. Yeah, you see this sometimes in games. So, linear and linear map not linear. Okay, so this definitely has an effect, and so what if we forget for a second RGB? X and Y. Oh wait, X and Y pixels, where each pixel is 4 bytes. But if we say each pixel 3 bytes, and let's do +3, let's forget the A for now, and this guy gives us an RGB. Let's see if we even see anything. Yeah, we do. It's broken. We have we have ass textures. Let's get this back. We have RGBA. I would really print. So let's print the bytes that we get, which we are doing. Anyway, Unsigned byte. RGBA. We might want to leave this till next time since we have taken so much time, but let's see, what do I want? So when we draw, we bind the simple material, we bind a mesh. We draw. This guy doesn't do much. Just the colors, which we don't use, it's only the UVs. Yeah, take coordinates as is, and we just use them. Okay, so that's not it. Color. Okay, so let's just print. I'd like to see the first one. So if x is 0, I want to compare the very first 2 bytes with the interleaved buffer, see if they're in the correct place. I think they should, but one way to know. Printf. So okay, so c.r g ba, right? And then in the mesh, Not in the mesh actually. This shouldn't matter. I want to check the UVs as well. Actually, that's the thing. This might be stupid, but let's just see. Okay, so we'll do this, and let's also see that the UVs are in the correct place. Because if the interleaving has any mistake, then we might be putting something else in the position of where the UV should go. Although I don't expect that was happening. So once we have the values for the very first one, let's say, okay, bunch of floats. So position 0, 1, 2, and then what do we have? We have 3, 4, 5 is the normal, and then we have the UV, which is 6 and 7. Okay, so 6 and 7. So let's say 26, and the value 7. Let's see if they match up with the actual texture coordinates. So let's say scene mesh text boards 0 and 0, 1, right? These should be the same. Just put this so you can find them, and these guys should be the same as well. What's that? Where is that? Okay. So dot x, right, and dot y. These are the components we're using. Should be the same as these. Ooh. Wood length, what? Load PNG at line 62. Does it make sense? We didn't change that. Whoa, what happened? What happened? 1, 2, 3. This is very weird. Line 62. Pixels. Oh wow. This should be 4, not 3. 4 bytes. Okay. Yeah, so these match up. The UVs are being loaded correctly in the correct place. And these guys, 1, 2, 3, 21, 29, 46 to 55, 21, 29, 46 to 55. Yeah. Now, obviously, these are fine. And then we plus 4, right? 0, 1. To the next iteration. Should we flatten it the other way around? Is that the issue? No, not really. X, Y. Actually, it might be. Should we load it column by column? Does that matter? Might flip it, but shouldn't do this banding that we see. Well, let's do this and see if it does something. Oh wow, okay, it's working now. Right, so the banding one we were seeing was all of the rows. Okay, that's crazy. Yeah, totally missed that. All the stupid debugging was wrong. No need. That's not it. The leaving was correct. So essentially, it was expecting the data to be there row by row. Sorry, column by column. Right. So all the y column and then the next column, so on. Is it? No, row by row. Yeah, I'm a bit tired today. Okay. X. So for a given y, we are loading. So y is 0. Yeah, so we load all of the y column. Of y. Yeah. So all the rows, we go down like this, one row at a time, top to bottom. We do that. Do we do X? No, row by row, actually, sorry. Sorry about that. So yeah, so we do essentially all the X, we put those. So as we flatten the array, we are flattening it in a sense that there were jumps happening. We were jumping from, as we were iterating over the Y, or going downwards. So what was happening is we have, that's our image, and we say these are our pixels, let's say. Completely forgot to think about how OpenGL expected the pixels to be in. But so we have this, and that's kind of right, row and column, and this is, let's say, you know, x0, y0, and I'm assuming, so it thinks this is y. This is x, all of these. So we had to go like this, right? This, and then we flow back, and we continue. So we come here, and then we continue. So we go row by row, like this. What was happening, which you didn't expect, and so we saw the banding issues, which is essentially a sudden jump to somewhere else. That's why we were seeing rows. We would go down like this. We would iterate on the y, and then go back up, and then go down. That's how we were storing the bytes. Instead, we should have stored them like as we do now, like this, row by row, essentially. This row, and then this row, and then this row, and so on. So our y set, like, let's say our y is 0, and then, you know, you have x0, and then x1, and then x2, and then x3, so 1 and 2 and 3. But I think that's pretty cool. So we managed to add actually a small sampling of an asset system, and then these. So that's our banding. So we want 0 and y's. Now we get this nice properly. So we have proper UVs that look just like Blender. So we have, what are we seeing? So we are seeing this side, right? And then, you know, as it's rotating and so on, we will see this side. It might be flipped, but yeah, it's not clear on a cube. But that should be easy to fix. Yeah, that's pretty nice. We have textures. We can load those. We load them from the mesh. I think that's it. That's pretty good. That is pretty good for today. We have this, and textures, let's go down. Asset loading, you know, it's not there yet, but it's happening. I feel like I forgot something I wanted to do. Well, all of this is fine. We can remove this. Yeah, so you have this guy in memory, and let's just make sure that we... All right, so you only have this one cube. All right, so let's just do one last thing, is let's put lights, because right now it's not being affected by the light source at all. It's just texture at full opacity, not opacity, full color strength. So I think we simply, as people are doing here, we just multiply thing, and that should do it. Where is it? So that's mixing. We don't have textures to mix from or to mix between. So let's take this. So we have a sample. Vec for text color, right? And then so our color is on the alpha. I don't want to change it. I want to keep it whatever if it's transparent, it's transparent. But on the RGBA, we're going to mix those RGB with all of these. So the color of the texture multiplied by the color of the lights multiplied by our ambience. Maybe. Cool. Very cool. So is the light actually affecting them properly? Ooh, wow. Okay. So yeah, they seem to light up on the right side. Let's increase. So that's the ambient. Very beautiful. So that's dark, right? Yeah, so this looks correct. Only the faces that are on the lights start to show up. And then if we have strong ambience, yeah, it's very nice. And if we have a low ambience, but then we can color the light, and that colors the texture as well. Well, nMage is growing up. So yeah, exported straight out of this texture in a separate file. We load at least PNG textures, which look fine. Now we only support 8-bit channels, which is okay. So maybe we can have it to do support, or maybe we have just it. We only support 8-bit channels, the 2-bit colors for now. Yeah, that's about it. Fragment colors. Move. Do we need this? Normal, vert normal. We have this. We don't need this. Okay. Let's confirm. Okay. And I assume we can still operate at like 10,000 cubes at a good frame rate. Yep. All good. That's crazy. That's all good. Now, if if we had so many meshes independently, that would be crazy. But luckily, we cache. We're using the same mesh, and it's all one texture. They applied. Very, very nice. Okay. So let's commit. We have anything? Yes, assets. So textures plus asset loading, basic asset loading, system plus UVs, right? Should be it, right? Thank you everyone so much for coming to the stream. This will be uploaded soon, and I'll see you next week. Bye bye.